Hello friends. So in this lecture we will be discussing about sorting techniques. There are many sorting algorithms. There are many sorting algorithms like insertion sort, selection sort, bubble sort, merge sort, heap sort, quick sort. But as part of C programming in your subject you have only three sorting algorithms. They are insertion sort, selection sort and bubble sort. So let us try to understand each technique one by one. So we will start with insertion sort. Insertion sort is a very simple algorithm and followed by selection and bubble sort. So let us first start with insertion sort. So friends, we will try to understand what is insertion sort. So let me explain with an example. So you can expect any one of the sorting technique as part of your external examination. So let me explain insertion sort. So please observe. Imagine I have an array of elements. By default, when we talk about sorting, we are talking about sorting the elements in the ascending order. Until unless it is explicitly asked, you need not think of descending order. So when we are asked about sorting, by default it is ascending order. So let us imagine I have an array and the array elements are 6, 5, 4, 3, 2, 1. So friends, this is the given input or the given array and I need to sort this one and my sorted output will be 1, 2, 3, 4, 5, 6. So in order to apply insertion sort, what is the procedure? So let us understand the algorithm or the procedure for insertion sort. So in insertion sort, we assume that we have two lists. One is the sorted list, another one is unsorted list. So friends, it is just an assumption. So logically we divide our array into two parts. So the first one, first element 6, this part is initially treated as the sorted array, right? And the remaining part of the array is considered to be unsorted array. So this is just an assumption. So we are not physically dividing, rather logically we treat first element as sorted array or the sorted list. Let me call it as sorted list. And this part, all other remaining elements are unsorted list. So friends, what we are supposed to do in this insertion sort algorithm is first we have to compare the first element of the unsorted list. The first element of the unsorted list will be compared with all the elements of the sorted list and accordingly swapping of the elements will be done so that the smallest element comes in its first place or so that the elements are ordered properly. So I repeat, we are going to compare one by one each element of unsorted list with all elements of sorted list. You will understand when you follow this example. So please observe carefully. So step 1, I have considered my sorted list, the first element as part of my sorted list. Now I need to compare first element of unsorted list with the sorted list. So friends, I'll be comparing 5 with 6. So there are only one element in the sorted list, so I'll be doing only one comparison. So 5 and 6 will be compared, and since 5 is less than 6, so 5 will be kept in the beginning and 6 will be written after that. So friends, now what will happen is this is my sorted list. Got it? So slowly in each iteration, the size of the sorted list will increase from 1 to n, whereas the size of the unsorted list is going to decrease. So 5 and 6 are now part of sorted list. So what is left in unsorted list? I have 4, 3, 2 and 1. Now I repeat the next element of unsorted list. So 5 has been now shifted to the sorted list. So what is the next element? 4. This 4 has to be compared with all elements of sorted list. So in this case, I have two elements in the sorted list. So first 4 will be compared with 6. 4 will also be compared with 5. So like that, 4, 5 and 6 will settle in the sorted list in the next iteration. Then I am left with 3, 2, 1. I'll compare 3 with 4, 3 with 5, 3 with 6 like that to make sure that 3 settles in its right position. So unsorted list elements are compared with all elements of sorted list. So in the next step, it will be like this: 3, 4, 5, 6. Then I'm left with 2 and 1. I'll be comparing 2 with all other elements, and I'll try to arrange it such that 2, 3, 4, 5, 6 are now part of the sorted list. And finally, I am left out with one element 1. And when I repeat the same process, this 1 will also be settled in its right position. And finally, my answer is the sorted list 1, 2, 3, 4, 5, 6. So friends, this is what is the procedure that is involved in the insertion sort. So whenever someone is asking you to explain any sorting algorithm, so please write 1 or 2 lines of brief explanation, not more than that. 1 or 2 lines is enough. Then try to explain the algorithm by taking an example like this. So if you explain the algorithm by taking an example like this, then it will be clear for the evaluator, followed by the program. So you have to explain things by writing a program. So program is mandatory. So let us see the program for insertion sort. So please observe. So friends, please observe here. So I have void main int I comma j comma temp p of 10. So here I am expecting the array size to be of 10. Of course, I can write a program using dynamic memory allocation, but I wanted to keep things simple, and my concentration is on the algorithm. So I wanted to make things very simple. So I'm using a static array of size 10. So keep in mind that the user should enter an array of something less than or equal to 10. So I'm asking user to enter the number of integers. So first I'll ask user how many integers he wants to enter. So obviously I said I can't handle more than 10 because my array size is 10. So I expect user to give something less than 10, less than or equal to 10 as n value, right? Now, after that I'm asking user to enter the values. So if the user said there are 5 integers, then you will be entering those 5 integer values. Using a for loop with a scanf statement, I am able to read those integers into a of I. So I am filling the array with the user input. Now please observe here, please observe this particular for loop, this one. So for I is equal to 1, I less than n, I plus plus. If you observe friends, array index actually starts from 0, but I am starting the I am starting my loop here from 1. It means that I am not going to iterate from the 0th element. The reason is very simple. By this time you might have guessed, because I just want to skip my first element. I just want to skip my first element. This is my 0th element. I don't want 0th element to be part of the iteration because the 0th element is assumed to be my sorted list. So I'll start from 5. I start from index 1, and from there I'll be doing comparisons. That's the reason my for loop has actually started from I is equal to 1. So a of I is copied in a temporary variable. A of I is 1. So a of 1, which is 5, is copied in a temporary variable. Friends, I am trying to trace this program with the example which we have discussed just now. So j is equal to I minus 1. When I is 1, j will be obviously 0. I minus 1 is 1 minus 1, 0. So I am comparing two things now. While j is greater than or equal to 0, and temp is less than or equal to a of j. So what is there in the temp? Temp contains 5. Temp contains 5. A of j means what? A of 0. A of 0 means the zeroth element, which is 6. 5 is less than or equal to 6. Yes, it is true. And j is greater than or equal to 0. Yes, j value is 0. 0 is greater than 0, greater than or equal to 0. Yes, it is true. Since both the conditions are true and the logical AND operation is used, I can enter into the while loop only when both the conditions are true. And in this case, both the conditions are true. So I enter into the loop, and please observe what we are doing in the loop. A of j value is 0. A of 0 is copied into A of j plus 1, which is 0 plus 1. It means that A of 0, it means 6, is copied into a location called as A of 1, means 6 is moved to the position of 5, and j is equal to j minus 1. Now j becomes minus 1. Minus 1 greater than or equal to 0. It is not true, so I'll come out of the while loop. And after coming out of the while loop, what I am doing? Temp is equal to a of j plus 1. Friends, if you observe just now, j became minus 1. So minus 1 plus 1 is 0. A of 0 is equal to temp. Means temp value 5 is copied into a of 0. So what is happening now? 5 and 6 were swapped. So please observe, if I repeat this process, now I plus plus I will become 2. A of 2, which is copied into 10. A of 2 is nothing but 4. 4 is copied into temp. Now again the process will be repeated. So if you trace this program based on the algorithm explained to you just now, so please note down this algorithm or the process on a paper, trace the program, line by line. You will understand how insertion sort is actually working. So friends, I hope insertion sort is clear to everyone. And once you write the program on your own, once you trace the program on your own, it will be very easy for you to understand, and you can easily explain insertion sort in your own words, and make sure you are going to explain even in your external examination. Make sure you are going to explain it with the help of the algorithm, example, and the program is mandatory, right? So hope insertion sort is clear to everyone. So let me move on to selection sort. Then similarly we will understand bubble sort. So friends, I hope it's clear, so let me move on. Yeah. So apart from insertion sort, there are, as I told you, there are many sorting algorithms, but we are interested in only three algorithms. Insertion sort we have seen. Now let us try to understand selection sort. Once, yeah. So friends, the next algorithm is selection sort. Yeah, selection sort. So for convenience sake, what I'll do is I'll take the same data, same array. So 6, 5, 4, 3, 2, 1. Imagine this is the array and I would like to sort it based on selection sort method. So let us understand selection sort. So what we do in selection sort is, in selection sort we will catch hold of our first element. Yeah. So what is my first element? My first element is my first element is 6. So in selection sort, what I'll do is I'll compare my first element with all other elements, and I'll try to swap if at all I find anything which is smaller than my first element, right? So I repeat, I'll compare first element with second element, means 1 will be compared with 2, 1 2, 1 3, 1 4, 1 5, 1 6. So 1 is my first element, which is 6. Its value is 6. So I have 6 elements, 1 2 3 4 5 6. So what comparisons I'll do? I'll compare 1 with 2, I'll compare 1 with 3, I'll compare 1 with 4, I'll compare 1 with 5, I'll compare 1 with 6. So 1 2 1 3 1 4 1 5 1 6. And in this comparison, during comparison, if I find anything which is smaller than my first element, I'll bring that smaller element to its right position or into the position of my first element. So in this process, what will happen is after every iteration, the smallest element will come into its correct position. Please try to understand this example by observing this process. So what I'll be doing, sir, I'll compare my first element with all other elements. So first, let me compare first element with second element, 6 and 5. If the second element is smaller than my first element, then I should swap it. So 6 and 5, 6 is greater than 5. So what I'll do, 5, 6. Now friends, what I have done here, I have compared my first element with the second element. So first element and second element are compared. Now the latest value of my first element is 5. So what I have done, only 1 and 2, 1 2 comparison is done, but 1 3 I need to repeat this now. So 5 and 4 should be compared. Now what will happen, since 4 is smaller than 5, 4 will come to this place, 6 will be here, right, 5 will be here, 3 2 1. Now what will happen friends, what is my latest first element? 4 is my latest first element. So first element compared with second element, first element compared with third element, 1 2 1 3. Now 1 4 compare with 4 and 3. 3 is smaller, so 3 6 5, right, so 4 comes here, 2 1. Now this is my first element. Of course my first element has again got changed and latest value of first element is 3. Now 3 is compared with, so 1 2 1 3 1 4 comparison we have done. Now we have to do comparison of 1 5. So again 3 is greater than 2, means the fifth element is actually smaller than my first element. So swap it. So 2 comes here, 6 remains like this, 5 4 2 1. So 1 2 1 3. So this is 1 2 friends. The first comparison, 1 2 1 3 1 4 1 5. Now 1 6. I need to compare 1 6 also. So what will happen? Again 1 is less than 2. So I should swap it. So 1 6 5 4 2. Something is missing. Yeah, actually this is 3, right? This is 3. So 1 6 5 4 3 and 2. So 1 6 comparison is also done. So 1 6 comparison is also done. Now if you observe friends, at the end of this entire iteration, what did you notice? The smallest element which is 1, smallest element is occupying its right position. Smallest element got settled. So what I am left with now, so 1 is now sorted and 1 is the smallest element in the array and 1 came into its correct position. So what I will do now, so I am done with my first element. I am done with my first element. So friends, what I am left with now, so I need not worry about 1 now. So what I am left with, 6 5 4 3 2. So I repeat the process now. So by skipping first element, I'm done with first element. So I repeat the process now. So second element will be compared with the third element, 2 3 2 4 2 5 2 6. So 6 and 5 I'll compare. I have to swap, right? Then what is the new element in my second position? 5. So 2 3 comparison is done. 2 4, 5 and 4 should be compared, and since 4 is smaller, swapping is done again. Then again 4 will be compared with the fourth element, 4 6 5, and this is the fourth element. 4 and 3 I compare, 3 6, 5, 4. Then again I'll compare 3 with 2. 2 is smaller, so 2, 6, 5, 4, 3. So friends, if you observe now, in the second iteration, the second element came and settled in its right place. So 1 and 2 got settled in right place. What I am left with? I am left with 6, 5, 4, 3. So I repeat this process on the remaining elements. Means third element 3, 3, 3 sorry 3, 4, 3, 5, 3, 6 comparison will be done, and accordingly swapping is done. Then the fourth element 4, 5, 4, 6. Then the fifth element 5, 6 is the comparison. Like that, if I repeat this process till n minus 1, all my elements will be sorted. So this process is called as selection sort. So friends, let us just go through the code and try to observe the code. So as I said again, I'm trying to restrict myself with a small array. I'm asking user to enter 5 integers. I'm reading the input using a small for loop. Then if you look at this for loop, so here this is the code for selection sort. So what I am doing, sir, I am running a nested loop. So for I equal to 0, I less than n minus 1, I plus plus, I am running or starting my loop from 0 to n minus 1, and in the inner loop I am starting it from I plus 1 and up to n minus 1 again. So what I am doing, please observe, if a of I greater than a of j, what is the value of I? 0. First value of I is 0. Initially when the loop begins, I value is 0. And what is j value? I plus 1. I plus 1 means what? 0 plus 1. So a of 0 is greater than a of 1. I am doing a comparison. If a of 0 greater than a of 1. So see here, what is a of 0? A of 0 is 6 and a of 1 is 5. 6 is greater than 5 or not? Yes, 6 is greater than 5. So I need to swap them. I have written the logic for swapping. I have written the logic for swapping. I am doing a simple swapping operation. Then it will continue like that. So I is now fixed at 0, but j value will change continuously. So what I am doing now, I remains 0, but j will become j plus 1. J plus plus will run, so j will become 2. Then a of 0 is compared with a of 2. A of 0 is compared with a of 3. A of 0 is compared with a of 4. A of 0 is compared with a of 5. Like that, it will run n minus 1 times, or from 0 to n number of times. And if at all there is a swapping required, if a of I is greater than a of j, swapping is done. So in one iteration, what will happen is the smallest element will come and settle in its right position, that is first position. Now what will happen, the inner for loop is completed. Then again I plus plus will run, I will become 1. Now when I is 1, there is no question of visiting the zeroth element. I is 1 means what? J will become 2. J is equal to I plus 1. So now I is fixed at 1. A of 1 means what? The second element. Now I is fixed at 1. Now again I am comparing it with J plus A of J, which is initially I plus 1. Means when I is 1, J will be 2. So I compare A of 1 with A of 2. If swapping is required, I will do it. Then J plus plus. So A of 1, A of 3, A of 1, A of 4, A of 1, A of 5, A of 1, A of 6, the last element. Like that, this second iteration will continue. In second iteration, what will happen? Second big smallest element or the second element will come and settle in its right position, that is second position, and it repeats like that. So it's a very simple logic, very simple algorithm. Just try to trace each and every line by comparing with the example given. Just now with the example which I have given, please use the same example to trace the program. Then you will be able to understand the code easily. It's very easy. So one simple point to be remembered is in selection sort, after every iteration, the smallest elements will try to come and settle in their right positions. right? In the first iteration, first element will settle in its correct position. In the second iteration, second element will come and settle in its right position, and it continues like that. So this is selection sort. So friends, similarly, we will look into bubble sort. So let me explain you bubble sort. Yeah. So another simple sorting technique is bubble sort. So as usual, I'll take the same example so that let me keep things very simple. So 6, 5, 4, 3, 2, 1. Now in bubble sort, what we do is we'll follow a different strategy, little bit different strategy. What we have done in selection sort is we were holding the first element, we were comparing it with all other elements. Means 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, like that we were doing comparison. Rather, what we will do here is we will compare 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, something like this. So I do a comparison like this. 6 is compared with 5. If required swapping is done, then 5 is compared with 4. 4 is compared with 3. 3 is compared with 2. 2 is compared with 1. So this is what we are going to do. And in bubble sort, if you observe in every iteration, in the first iteration, the biggest element or the largest element will settle in its right position. Whereas in selection sort, in first iteration, the smallest element will come in its first place or in its right place. Whereas in bubble sort, it is quite opposite. It will be sorting the elements in a different direction. So in every iteration, the biggest element will come and settle in its right position. Then the next biggest, like that it will come in the reverse direction. So if you observe, what I'll do in bubble sort is we'll compare first element with second element. 6 and 5 are compared. So what will happen, since 6 is greater than 5, we will swap them 5 and 6. Then 4, 3, 2, 1 as usual. Now what we will do, we will compare second and third element. So 5 remains here. 6 and 4, 6 is greater than 4. So again swapping is done. 6 will move on. Then what we will do, we will compare 2 and 3 comparison is done. Now 3 and 4. So 6 and 3 are compared. So now what will happen? 5, 4, 3, 6, 2, 1. Now I'll compare these two elements. Again 6 is greater than 2. So in the next step what I get is 5, 4, 3, 2, 6, 1. And in the last comparison again 6 is greater than 1. So 5, 4, 3, 2, 1, 6. So friends, if you observe in first iteration, the largest element 6 got settled in its right position, that is the last position. So in the next iteration, what we will do is we will not consider the last element, means we will repeat this process, but we repeat this process up to fifth element only. So what I am left with, I am left with 5, 4, 3, 2, 1. So I need not consider the sixth element. Sixth element is already sorted. So again I repeat the process. So 5, 4. Then 5, 4 means what will happen? 4 and 5 are swapped. 3, 2, 1. So compare 5 and 3. So what will happen? 4, 3, 5, 2, 1. Then 5 and 2 are compared. 4, 3, 2, 5 and 1. Again 5 and 1 are compared. 4, 3, 2, 1, 5. So what is happening in the second iteration? The second largest element got settled in its right position. So what I am left with is the remaining 4 elements. So repeat this process on remaining 4 elements. So like this it will continue till all the elements are sorted. So friends, if you observe the code, so let me show you the program for bubble sort. Yeah, so void main again, I'm trying to keep things simple. So this is the code. So please trace this. Please trace the code the way we have traced uh, insertion sort and selection sort code. You please also trace the code for bubble sort. So this is how you understand after writing the algorithm. When you trace the code, then you will understand how to sort the array elements. So I hope insertion sort, selection sort, and bubble sort are clear to you. So maybe in the next session we try to discuss searching techniques, searching algorithms. So I hope sorting all three sorting algorithms are clear to everyone. Thank you.